This question is asking for mass percentage of iron in the metal sample. So again, make sure we understand what we mean by mass percentage or weight percent. So we need to know the mass of iron and divide that by the mass of the metal, or the mass of the sample, and multiply by 100 to get a percent. So that will be percent weight per weight. In this particular question, we don't know either the mass of the metal or the mass of the sample. So let's look at the mass of the sample first. We don't know that directly. What we're going to have to do is figure it out, and we are given the density. So if we know the volume of our piece of metal in centimeters cubed, we can figure out what mass that is from the density. So first of all, let's do the volume. So we know it's 5 centimeters by 5 centimeters square, and 1 millimeter thick, so we want to convert that into centimeters also. And there are 10 millimeters in a centimeter, so 0.1. Multiply those together, we end up with 2.5 centimeters cubed. Now if we multiply that by the density of the metal, 7.8 grams per centimeter cubed. Centimeter cubed will cancel out, and we end up with 19.5 grams. So now we know the mass of our sample is 19.5 grams. To find the mass of the iron, again, we don't know that directly. We have to know what the precipitate is. We know a mass of a precipitate, but first of all, let's figure out what is that precipitate. What it tells us is that we're adding iron, or we're increasing the pH of the solution, which means adding hydroxide. And we've got to add 3 of those because we're told this is iron-free hydroxide that's formed. So iron is in the +3 oxidation state. And when you form this hydroxide precipitate, what you find is you get this orange gelatinous kind of solid because you've got water as a crystallization in it. Okay, so we can't weigh that and know and calculate the exact number of moles. So what we have to do is convert it, and we do that by ignition, by heating to about 1,000 degrees in a crucible. And when you do that, iron is going to be in its most oxidized form, so it's still going to be 3+. But now we drive off water and also some of the hydroxide as water, and we're going to end up with iron-free oxide. So iron 3+, oxygen is -2, so it's going to be Fe2O3. Now we know the exact formula. Okay, if we know the exact formula, we can figure out the formula weight, or the molar mass, and that is going to be 159.7. So it's the atomic mass of iron times 2 plus the atomic mass of oxygen times 3. And then we can figure out how many moles of iron oxide by dividing the mass of the precipitate by the formula mass, and that gives us 0.02693 moles. The important thing here is to know that this is the moles of iron oxide, not of iron. Okay, there are 2 irons in every iron oxide, so we need to multiply by 2 to find the number of moles of iron. So this will be 0.05385 moles. Okay. Now we need to know the mass of the iron, so we're going to multiply by the atomic mass of iron, grams per mole. It ends up giving you 3.01 grams. Now we know the mass of the iron. We can put that into the mass percent. So 3.01 grams divided by the mass the mass of the metal, excuse me, 19.5 grams multiplied by 100, and to 2 sig figs, that's 15% weight per weight.